Welcome to the Astro Guy podcast. I'm not an expert, I'm an amateur like you. I'm here to learn and here to teach. So let's enjoy the ride together. Carpe Noctem, seize the night.
I'm your host, Wayne Zool, and this is the Astro Guy podcast. Holiday greetings. NASA has delivered a wonderful Christmas present to the world. At 7:20 a.m. Eastern Time on Christmas morning, the James Webb Space Telescope finally launched after years of delays. It is currently on its way to the L2 LaGrange Point, more on that in a bit, where it will hopefully spend several years making amazing discoveries. Touted as the replacement for the Hubble Space Telescope while working at different wavelengths, the James Webb Space Telescope, or JWST, is a very different instrument. Hubble, which was launched aboard the Space Shuttle Discovery on April 24, 1990, is still in orbit and is expected to continue orbiting the Earth in low Earth orbit for another 10 to 20 years, and should keep making observations as long as its equipment keeps working. Hubble is an amazing instrument. Its primary mirror is 2.4 meters, or 7 feet 10 inches in diameter, and it is designed to observe objects in the ultraviolet, visible, and near-infrared parts of the spectrum. Its primary mirror is a single piece of glass that was formed with a honeycombed back to make it light and sturdy. Hubble has made incredible discoveries and sent back amazing pictures of a multitude of celestial wonders. Hubble's pillars of creation and deep field images should be familiar to most anyone. JWST, on the other hand, is a very different instrument altogether. Rather than having a single large mirror to gather light, its mirror is made up of 18 1.2 meter hexagonal segments. This gives JWST an aperture of 6.5 meters, meaning that its total surface area will collect about 6 times more light than Hubble, and it will be able to resolve details about as small as 70 milliarc seconds, meaning that it could read the writing on a penny from more than 25 miles away. The segmented mirror design isn't new. There are many large ground-based telescopes that have similar designs. The difference here is that the mirror segments for JWST need to be folded for launch and then unfolded and locked into position once it's on its way to the L2 point. Another major difference between JWST and Hubble is that JWST is designed to observe in the infrared, meaning that it can detect the heat energy of objects even if they're obscured by dust. It will be able to see further and in more detail than the Hubble Space Telescope does. The telescope has 4 main instruments: the near-infrared camera, or NIRCam, which will observe objects at a wavelength of 0.6 to 5 microns; the near-infrared spectrograph, or NIRSpec, which operates at the same wavelengths as NIRCam, but which will only look at the spectra of objects as opposed to imaging them. This allows us to see the light broken down into its component parts, revealing what elements are present. The third instrument is the mid-infrared instrument, or MIRI. This will be able to image both the object and its spectra at the same time, and will be operating at wavelengths between 5 and 28 microns. According to NASA, and I quote, "Its sensitive detectors will allow it to see the redshifted light of distant galaxies, newly forming stars, and faintly visible comets, as well as objects in the Kuiper Belt." MIRI's camera will provide wide-field, broadband imaging that will continue the breathtaking astrophotography that has made Hubble so universally admired. The spectrograph will enable medium-resolution spectroscopy, providing new physical details of the distant objects it will observe. The fourth instrument, the FIG's NIRISS is the Fine Guidance Sensor, or FGS, which allows Webb to point precisely in space. NIRISS, the Near Infrared and Slitless Spectrograph, will be used to investigate the following science objectives: first light detection, exoplanet detection and characterization, and exoplanet transit spectroscopy. FIG's NIRISS has a wavelength range of 0.8 to 5 microns and is a specialized instrument with 3 main modes, each of which assesses a separate wavelength range. FIGS is a guider, which helps point the telescope accurately. When it was launched, the JWST was folded up, and over the next several weeks, as it makes its way to L2, it will slowly unfurl its heat shield, mirrors, and other instruments. When everything is in its place, the JWST will be about the size of a tennis court. Most of that area is made up of the sun shield, which blocks sunlight from the mirror, as well as keeping its instruments at the very cold temperatures that they need to be to operate properly. So what is the L2 LaGrange point? I'm going to put it in simple terms because I don't understand the math. There are 5 different points where a small object can be in an orbit, keeping it in the same position in relation to 2 large masses, in this case, the Sun and the Earth. I found that the best way is to think of these as gravity wells. The L1 is a point about 1.5 million kilometers, or just over 932,000 miles, directly between the Earth and the Sun. There are several satellites at the L1 point, including SOHO and the Deep Space Climate Observer satellite. The L2 point is the same distance from Earth, but in the opposite direction. The Earth is between L2 and the Sun. This is where JWST is going to be doing its work from. There are a few other satellites currently at L2. Of note is the ESA's Gaia probe. L2 is ideal for astronomy because a spacecraft orbiting here is close enough to readily communicate with the Earth, can keep the Sun, Earth, and the Moon behind the spacecraft to provide for solar power, and, with appropriate shielding, like JWST has, a clear view of deep space. The L3 point is on the opposite side of the Earth's orbit, basically where the Earth will be in 6 months. The L4 and L5 points are on the same plane as the Earth's orbit and lie ahead and behind the Earth. This is where the Trojan Asteroids are found. Trojan Asteroids have been observed traveling in the L4 and L5 points of Earth, Mars, Jupiter, and Saturn. To keep tabs on where the JWST is and what activities it's performing as it continues to unfurl itself, visit web.nasa.gov. That's all for this episode. Thank you so much for tuning in, and I hope that you found our time together to be fun and helpful. If you have questions or episode suggestions, please email us at astroguypodcast@gmail.com or leave us a voicemail at 973-404-0380. If you're not already a member, please join the Astro Guy Podcast group on Facebook. You'll find other members, videos, blogs, and lots of useful information there for your enjoyment. You can also visit our YouTube channel, the Astro Guy Podcast, for past episodes and other surprises. Thank you again for listening, and may your skies be clear. And as always, Carpe Noctem, seize the night.
I'm Wayne Zool, and this was the Astro Guy Podcast. Thank you for listening. As always, your questions, comments, and suggestions are welcome. Keep wondering. Keep your eyes on the sky. Have fun. Carpe Noctem. Seize the night.